Hello, and welcome to a quick crash course video in segment length rules for circles. So you should be looking on with this video and maybe a document called segment lengths. And we're going to talk about how long different pieces are inside or outside a circle. So first one says, if we have intersecting chords inside a circle, remember that a chord is something that touches both sides of the circle. So if I have this chord right here, intersecting this chord right here on my screen, they're red and blue. If you want to know how long each of those pieces are, the formula for this picture would be A times B equals C times D. The product of the two segment lengths is equal. A times B equals C times D. And sometimes I write that as part times part equals part times part. That doesn't seem very helpful right now, but when you compare it to some other rules, it will be. All right, so part times part equals part times part. So if we come down here, it says find the value of x. Well, here's a chord, and here's another chord. So part times part would be 4 times 12. And then part times part is 6 times x. So 4 times 12 is 48. 6 times x is 6x. And then I solve for x by dividing by 6. And I get, I think, 8. Ta-da! X is 8. If I come over here to the other one, nothing's filled in for me, so I'm going to fill it in myself. Not a problem. It says DE is 11, so that means this whole thing is 11. BF is 10. DF is 8. Okay, so if DF is 8 and the whole thing's 11, I now know that this is 3. And they want me to find FC. Okay, so I'm going to go back here and erase the 11 to just get it out of the way. And then say, oh, these are two chords again. Part times part equals part times part. 8 times 3 equals 10 times x. Divide by 10, and I get 24 tenths, which is 2.4. Ta-da! So when you have two chords that intersect inside a circle and make an X, part times part equals part times part, and then you solve for what's missing. Awesome. Next, what if they don't stay inside the circle like chords? What if they jut outside? Well, if they jut outside, they are called secants. And so this length right here, this whole green thing is one secant, and this other green thing is another secant. And we want to find, I don't know if you can hear my phone dinging, let me silent it. If I have two secants, there is a different rule. So for this one, the rule would be W times, now not W times X, it's a W times W plus X equals Y times Y plus Z. So it's W times the whole thing and Y times the whole thing. So the rule that we make here is we do the outside times the whole equals the outside times the whole. So for chords, it's part times part. But once you do outside the circle, then it's outside times whole equals outside times whole. So if I come down here to this one, I have two secants. The outside is 14. The whole thing is 34. For this one, the outside is 16. The whole thing, now we're going to be careful, is 16 and x, which isn't 16x. It's 16 plus x. To get the whole, make sure you're adding. So if we do outside times whole, I have 14 times 34. And if I do outside times whole here, it's going to be 16 times 16 plus x. So if I want to solve for x now, I'm going to say, all right, 14 times 34. I'm going to pull up a calculator here. It takes a while. You can obviously do this with your calculator from school. You can use your phone. Let me shrink this a little bit here. So I was supposed to do, let's see. I want to make this small. My apologies for how obnoxious and annoying it is watching me fumble with my calculator. Okay. So I was supposed to do 14 times 34. That is 476. 16 times 16 is 256. 16 times x is 16x. And now I'm going to subtract 256 and get, what's this, 220, and then divide by 16. So 476 minus 256 is 220. I was right. Divided by 16 is 13.75. All right. Besides taking a minute to fumble with my calculator, what you should have learned on this page so far is that if you have two chords that intersect to make an X, it's part times part equals part times part. If instead of an X, you get a V that pokes outside the circle, it's outside times whole equals outside times whole. Now, what if instead of two secants, you do have stuff on the outside, but one of them's a tangent and the other one's a secant? Well, technically, what that just means is that on that tangent segment, the outside is the whole. So outside times whole equals outside times whole really becomes tangent squared equals outside times whole. So for this picture, t squared equals y times y plus z. All right, so outside times whole equals outside times whole shrinks down when you have a tangent to tangent squared equals outside times whole. Quick example here, z happens to be my tangent, so that thing's going to be squared. The outside down here is 8. The whole thing is 8 plus 16, which is 24. So I have z squared equals 8 times 24. So then I have z squared equals 192. And if I square root it, let's get a decimal going for this one. So if I square root 192, I get 13.856. We didn't tell you what to round to, so I'm going to round that to 13.9. And there's z. Okay? And the nice part is I saved the easiest one for last this time rather than putting the easy thing in the beginning. What if they're both tangents? Easy. They're equal. If you have two tangents, they are always going to be equal to each other. So tangents from the same external point are congruent. So in this case, that means AB is congruent to AC. Easy peasy. When we come down here, what if I made like a triangle outside of a circle? Well, I can use this tangent idea. So if this says find the perimeter of the circumscribed triangle, that's the triangle on the outside, I would say, okay, well, these two red lines are a tangent from there. These two green lines are a tangent from there. And you guessed it, another pair of tangents down here. So if I want to figure out how long each of those are, the tangents just have to be equal. So if this part's 5, so is that. If this part's 4, so is that. If this part's 3, so is that. So the perimeter of this triangle is just the length of all the sides. So this is 7, 8, 9, and my perimeter's 24. That's it. 3 kind of 4 rules to remember here. Part times part equals part times part if they intersect inside the circle. If they intersect outside the circle, it's outside times whole equals outside times whole. If instead of having an outside and a whole, you have a tangent, it's a tangent squared equals outside times whole. And if it's a tangent and a tangent, they're equal. Done. I hope everybody's having a great day today. I know I am because I'm not even wearing regular pants. I'm wearing pajama pants because who puts on regular pants anymore? Excellent day, everybody. I hope you have a good one.